Oh, I just made it bad. The delightful thing that I have a lovely view of the quad, but the problem is that I get the afternoon sun just like beating in on this side. Good afternoon, everyone. We're going to wait just one more minute to give folks a little bit more time to pop in. So we'll start very shortly. All right, well, let's go ahead and get started. Good afternoon, everyone. My name is Deanna Hentz, and I'm a professor of atmospheric sciences at the University of Illinois at Urbana-Champaign, and I'm also lead of the engagement and partnership team for iGuide. I would like to welcome you to this installment of the iGuide webinar series on digital storytelling through data visualization. And thank you so much for your attention around this very important topic. As iGuide works to weave a variety of disciplines together around geospatial problems of resilience and sustainability, telling that story through innovative science communication is a central iGuide priority. We are very fortunate to have a key partner in our science storytelling efforts through the NASA Scientific Visualization Studio, who have delighted people around the world with stunning visualizations of our planet and beyond. As such, I am honored to introduce Mark Subbarao, head of the NASA Scientific Visualization Studio, who will introduce our speakers and serve as panelists for today's discussion. Please take it away, Mark.
Thank you, Deanna. I'm very excited for today's conversation. I know many of you have heard the saying, science isn't finished until it is communicated. And as science gets more complex, visualization is really the best tool to convey complex science. So we're going to hear about different ways to do that today. And I think we're really fortunate within iGuide to have a number of the world's experts in visualization. And, uh, and today we're really going to talk about not just using visualization to understand data, but to communicate and to tell stories with that data. So we have two fantastic speakers. The first speaker will be Vetria Byrd. Vetria is an associate professor of computer graphics technology in the Polytechnic Institute at Purdue University in West Lafayette, Indiana. She uniquely integrates scholarship in teaching and learning and engagement through a purposeful research agenda that focuses on developing a progressive learning path for teaching and learning data visualization, and addressing the existing gap in visualization on how and what to teach diverse audiences in diverse settings about data visualization. She is the founder and organizer of BP Viz, Broadening Participation in Visualization Workshop, which aims to broaden participation and build data visualization capacity of women and persons with limited access to visualization resources. She is a member of the NSF-supported iGuide Education and Workforce Development Team. So Vetria, why don't you take it off?
Thank you so much, Mark, and thank each one of you for your time and attention today. I'm always excited to talk about what I do, which is introducing data visualization to a number of groups who may or may not have access to data visualization resources. So today I'm going to give you a very high-level overview of the basics. So first I want to start off by saying or addressing what is data visualization. So data visualization is the transformation of data in whatever form that it might be into a visual representation that provides a deeper understanding of subtle, unexplored patterns and relationships that exist in that data. And so what you want to try to think about is how do we go from data to insight? Because the purpose of data visualization is insight, not just the pretty pictures. So the pretty pictures are the icing on the cake. So what you want to think about is what are the underlying patterns and the underlying information that you're dealing with when you talk about data visualization. So in this particular slide, I'm showing how to go from data to true insight. And as you start out with data, you look at the relationships that exist in that data that forms information. When you identify patterns and relationships that exist in the data, you establish a knowledge base. From that, you're able to gain more understanding of what the data represents and perhaps some principles that can be applied to that data. And ultimately, what you want to be able to do is to make some predictions. And so you want to be able to ascertain or to share those insights that you found by looking through and exploring that data more intently. So from a pedagogical data perspective, data visualization is a multi-stage, iterative, non-linear, sometimes messy and complex process. And so as I mentioned in the previous slide, one of the things that I try to do is to think about how to teach data visualization to persons who may or may not have the background in studying data viz. And so as you can see in this slide, it allows you to go from lower order thinking to higher order thinking. And these are the stages that I particularly use in my classes that I teach. But you will find that sometimes these stages or steps have different names, but you're basically doing the exact same thing, or you're incorporating all of these things, these elements, into actually making sense of the data. So you have to acquire the data, which means find some data sources. You have to then parse that data. What does it look like? And so parsing will give you a better idea of what to expect when you start to actually mine and filter the data. Filtering allows you to focus on just that part of the data that you're interested in. More than likely, your data will be larger than what you need to begin with to answer a specific question. So mining that data, looking at those relationships that I mentioned, maybe trying to figure out some questions that can be asked and answered with that data. That's what happens in the mine stage. I also want to point out that each of these stages has a body of work or knowledge that can, and time that can be spent in each of these stages at any given time. So the represent stage is the linchpin of this process, because it is at this process or this stage in the process that you actually start representing or visualizing what you've been working on. And this is where you show your audience, identify who your audience members are, because your audience will dictate or determine how that representation is presented. Getting feedback or critiques, very important. I think all of us have had an experience where you have created your masterpiece and then you show it to a friend or a colleague and they get a totally different interpretation of what you were expecting. And so feedback is very important. And that feedback allows you to refine the visualizations that you created. And it also ensures that you're on the right track. And then lastly, to be able to interact with the visualizations that you're creating is also important, that it allows the person who's viewing your work to dive deeper into what you are processing or what you're presenting. So I want to say or point out that you can be in any stage of the data visualization process at any given time. So in the previous slide, I showed a process which was very much linear, and I chose that workflow for introducing data visualization to what I call novice users or beginners. But again, you can be in any of these stages at any given time. They may be called different things. For example, in this slide, it shows data sources. That is your acquire stage. Data modeling and data preparation. That could be your mining and your parsing stage. So as you can see in this slide, it's showing the principles of data visualization. And one thing that's missing here that I've added and I talked about in the previous slide is the critique. The critique or that feedback, very important. And so you want to consider that as a part of your data visualization process to make sure that if you're collaborating with someone, that you're speaking the same language. Oftentimes, as a computer scientist by nature and by preparation, I will have something that I think is correct visually, and then I'll show it to a collaborator and it's pretty, it's nice, but what do you think about this? That's usually sometimes the response. So that feedback is very important and critical to the process. Most likely you've heard of information visualization, but also there is scientific visualization as well. And so this is a different pipeline. But again, as I mentioned in the previous slides, all of these stages or these steps that I've mentioned, you will see them in the scientific visualization pipeline as well. Your first visualization tool will not be your first tool that you learn and you use, and your first visualization that you create will not be your last. And as you can see in this particular visual, it shows you the stages that the data goes through or the transformations that the data goes through as you are working through this process. And this allows you to see all of the different stages that are utilized. So the data really dictates the type of tools that will be used for representation. Remember I said the purpose of data visualization is insight. And so what this insight allows us to do, several things. It allows us to explain things more clearly. It helps in the analysis of data. It allows us to make discoveries that we may not have known were there. It also informs decision-making, and last but not least, storytelling. So that's what this is all about. Data visualization, I think, is a gateway to other disciplines. It is a conduit for collaboration, a pathway to enforce STEM and STEAM, a mechanism for broadening participation, bridging science and technology. It's also a catalyst for communication, and it can be used to facilitate public outreach. And so whatever your background is or your research is, at some point, you will visualize data. We cannot escape it because it's everywhere. And so the question that I pose to you is that, what story do you want to tell and how do you want to tell it? And so what we're presenting today is an opportunity or a way in which you can engage with the data and to show you some ways in which we've utilized visualization for these purposes. So in the interest of time, I am just going to provide you with some resources here in terms of data visualization sources, things that I think would be good for beginners, and also a data visualization tools website that gives you a wealth of different types of tools and visualization books that you can refer to. Also, I've listed my contact information, and so I will hand it over to my colleague, Kalina, to pick up with how data visualization can be used for scientific communication.
Thank you, Vetria. So yes, our next speaker will be Kalina Berkevitz. Kalina is the director of the NCSA Visualization Program Office and the Advanced Visualization Lab. She has been creating scientific visualizations for public outreach since 2014, and the AVL team has a history going back to the 1990s under Donna Cox. Kalina has a computer science background and has contributed to a number of visualization software efforts, including Ytini. She is also a member of the NSF-supported iGuide engagement and partnerships team. So, Kalina, why don't you take it over?
Thanks for the introduction, Mark, and for the setup, Vetria. Sorry, I shared the wrong part of the slides. Bear with me for a second. Play from current slide. So Vetria offered an excellent introduction to data visualization broadly, and the entire field of visualization includes everything from bar charts to maps to documentary films. So it's a very broad field. And I'm going to be speaking about one very specific type of visualization that I do as part of my teamwork with the Advanced Visualization Lab that we refer to as cinematic scientific visualization, or CSV for short. And this type of visualization is most ideal for communication with the general public and public outreach. So one of the best ways of defining cinematic visualization is by showing it in contrast to more traditional types of visualization. So I'll start by showing a couple different examples. So here on the left, I'm showing two images from a scientific journal article showing the Pine Island calving ice sheet in Antarctica. And on the right, I'm showing the same event, but in a cinematic visualization style on the right versus kind of the traditional style on the left. So hopefully the differences should be quite obvious, but just to kind of talk you through some of the things that are different about the visual on the right. We started off the video by not just showing this Pine Island area and the calving event immediately, but we started out with the larger picture. We introduced the whole scene. This is happening in Antarctica, so we started off with a global view. Now we can actually see this ice breaking apart, and we take this as an opportunity to dive the camera into the crater and provide this kind of roller coaster ride type feeling, taking our audience through this 3D virtual scene in a way that is immersive and exciting. And this video on the right is created for general audiences. This was actually created for a documentary film titled Atlas of a Changing Earth. And it might be playing in a planetarium near you. And if it isn't just yet, it might be shortly. So the intended audience for cinematic scientific visualizations is often the general public. So this includes children that might be going to the museum with their parents or their grandparents. This includes non-experts, as well as scientific experts also. We do want the data to be accurate as possible, and so that a scientific expert that is looking at this data can also get value out of it. In addition to it only just being beautiful and entertaining, it is still scientifically valid and accurate. Here's another set of examples. So these visualizations are both showing Chicago traffic. So the image on the left is a screenshot from Google Maps, and the image on the right is a video by the Advanced Visualization Lab team. In the left image, it's a still, but the Google Maps software, I'm sure you're all familiar with, is interactive. The goal of it is kind of more data exploration. You can zoom in and see what's going on, as well as have it actually track you when you're in your car and show you real-time information. Whereas the visual on the right has a very different purpose, obviously. It's not just a different audience in terms of being more general, but the way that you interact with it is very different. The goals of it are very different. So not saying that one style is any better than the other. They're intended for different audiences, different purposes, and they have a lot of differences for that reason. So what makes a visualization cinematic? One of the main things is the aspect of storytelling. So here I'm just showing a bunch of different visualizations that are all showing different types of geospatial data. The image on the left, top left, is showing the Global Lambda Integrated Facility Network called GLIF. It's a high-speed internet connection that connects research institutes around the world. On the top right, we're seeing terrain from an area that had a great flood occur in the 1920s. And that video starts off by following just the terrain and showing in 3D. But if you watch it long enough, you'll see that it converts into a more map-like diagrammatic representation. That's about to happen here shortly. In the bottom left, we're showing a storm cloud forming over a specific area of Joplin, Missouri. So we're using geospatial data as the base for this kind of atmospheric science data simulation. And on the right, we're looking at a data set of tree counts in Africa. So there's a scientist that did a lot of analysis on satellite imagery to locate and count individual trees in this area of Africa. And again, we started off this shot by kind of looking at more of the whole continent and then dive in to look at the area of a single tree. So in each of these visualizations, we're trying to tell some kind of a story. And in some cases, when it's created for a documentary film, for example, that story can be explained with a narrator that's perhaps talking about what's going on. But in the image on the top right, you see that there's actually some text appearing over it, and that helps tell the story, even just looking at the video without any narration. But the camera itself, the way that it moves is also used to kind of drive that story. And even if there is no sound or no text, the story is still being told just by the design choices that are being made with specifically the positioning of the camera and where it zooms and where it starts and where it ends. Context is very, very important in creating these types of visualizations. Oftentimes, a scientific data set might focus on one very specific piece of some larger picture. So providing that context to a general audience is very important when creating a cinematic visualization. The 3D design is an important component. Usually, data sets that can be visualized in this way are spatiotemporal, so evolving in both time and in space. And we put them together into a 3D virtual scene so that we can do things like move a camera around and change things like lighting and add shadows and effects like that that can add a lot to the emotion of the scene. In terms of visual treatment, sometimes photorealism can be attained and can be effective in creating something that looks beautiful and cinematic and realistic, but that's not necessary. You can create abstractions and also have those be cinematic as well. Oh, started that too soon, so I forgot to introduce it. Next, I'm going to show you a brief little video that shows some of the Advanced Visualization Lab's broader work, not just geospatial visualization, but scientific visualizations more generally. So the Advanced Visualization Lab team is what we like to call a Renaissance team. This is a term coined by Donna Cox to describe this combination of people with different skills that get together to produce this type of work. So on the one hand, we have scientists and domain experts that we work together with very, very closely. So we are visualization experts, but we aren't experts in all of the different scientific fields. You saw in the video just now that there were geospatial data sets, but also astrophysical data sets and biological data sets. We can't be experts in all of those things, and we don't pretend to be or try to be. So we work with the people that actually do know those fields very well, and they offer their feedback and guidance and advice on the visuals that we're producing. Then within the AVL team, we have designers and artists who really have a focus on the aesthetic side of things and creating visuals that will communicate the science to our target general audiences most effectively. And then there's the technologists and the programmers. This is the area that I come from myself, that create the tools for the artists and do a lot of the data processing. And all of these people work together. We all get together to work on these problems and pass things back and forth, get feedback from each other. And it's really a collaborative effort to create these types of visualizations. Here is a sampling of movie posters that the AVL team has contributed to over the years. Many of these are available on streaming services or can be seen on international television and IMAX films. Some of these are planetarium dome shows that have been distributed internationally to museums. So you might have actually had a chance to see some of these, or maybe some of our other work that isn't necessarily featured on this slide. Many of our visualizations are award-winning as well. This slide just goes back to 2015. And I'm not really just showing this slide to brag, but what I kind of want to get across with this is the fact that these types of visualizations get a lot of eyes on them and have a really broad impact. And impact is something that is really important to organizations like the National Science Foundation and other funding agencies. The NSF actually requires a broad impact statement in a lot of grant proposals. It's really important to these organizations, and hopefully to scientists and researchers as well, that the research that is being done doesn't just stay within the scientific community and locked down, but it actually gets spread to the wider public and has some good in the broader world. So cinematic visualization is one of the types of ways that you can have this really broad type of impact and take science that might be really cutting edge or really complex and difficult to understand or difficult to explain, and figure out how to explain it in a way that is not only understandable, but also interesting and appealing to people all over the world, to people of all educational backgrounds and age differences. There's this potential to reach really diverse audiences. And just as a couple examples, the Museum of Science and Industry in Chicago is a museum that we've worked with in the past that has a science storms exhibit that features one of our tornado visualizations. They are also an iGuide partner. And just from their Wikipedia page, you can see that they get 1.5 million visitors every single year, just about. I'm sure that went down a little bit during COVID, but numbers are coming back up. So having a visualization, distributed through a museum like this would really get it in front of a lot of people. You don't necessarily even have to, partner with something like a large museum in order to put a visualization out there and have a lot of impact. Things like YouTube and social media are obviously a great ways to share content as well. Space Trip is one YouTube channel owned by Thomas Lucas Productions, who is also an iGuide partner that has a wide viewer base. And here's a video from about Earth data with a visualization that has 19.5 million views. That's not to say that every cinematic visualization ever made that you put on the internet is going to go viral and make it big and change the world, but it certainly has potential to do that. A lot more than kind of the more traditional way of communicating science, As researchers and academics, you're probably very familiar with, publications and citations. That's accounts that's very important in this line of work. But even in the best possible case scenario, if you're in the top 0.026% of publications, you would be lucky to get, a few hundred citations. So comparing the numbers, millions of people, potential of millions of people seeing your visualizations created in a cinematic style and distributed either online or through partners, versus just leaving it within the scientific community and publications. Hopefully, it should be clear that this is worth investing in, worth investing the time and effort to create these visualizations that could communicate the science in a broader sense. So I mentioned a couple iGuide partners. Here's a slide that has some additional logos. iGuide hasn't quite finished defining what a partnership means for all these different types of organizations, but for now, I'm just putting these logos up to show that these are people that have, or these are organizations that have expressed interest in geospatial data and science communication with the general public. So there are opportunities here to collaborate with these institutions and organizations. And of course, Mark Subbarao from NASA's Scientific Visualization Studio is here with us today. So I have another video I'm going to play. This is kind of a behind the scenes video that shows a little bit of what went into creating one particular cinematic scientific visualization that my team created recently.
Here's what went into making a piece of Atlas of a Changing Earth. We built on the results of the Arctic DEM survey project. That survey used high-resolution satellite imagery, hundreds of thousands of observations spanning several years, and measured the Earth's shape in fine detail, covering all the land north of 60 degrees latitude. Transforming that imagery into this mapped dataset of Earth's topography required millions of hours of Blue Water's supercomputer processing. Satellite observations were in strips, a few kilometers long. Throughout the survey, many areas were observed on dozens of occasions, revealing how Earth's topography changes with time. This shot from Atlas of a Changing Earth animates the multi-year Arctic DEM survey in the context of a realistic-looking Earth. The visualization incorporates seasonal changes in Earth's appearance. We created it in layers. On the ocean is a climate model simulation of sea ice coverage. To design the unbroken animation path around the world and into Vavilov, we used AVL's interactive Virtual Director software. Virtual Director shows a simplified preview of the scene in the correct 3D location. Final rendered elements fit right in. Datasets, camera paths, and so on are brought into the commercial software tool Houdini from Side Effects. Its node-based architecture supports a mix of programmable and interactive design. The DEM survey data shows exquisite detail, but contains many artifacts, thanks especially to clouds. Seen in a 3D landscape, every defect becomes even more prominent. Lots of manual work went into cleaning the raw survey data, masking out clouds and aligning strips with each other. The DEM data was observed at discrete times at irregular intervals, days or months apart. To give the sense of continuous motion, we used morphing interpolation in Nuke on the high spatial frequency ripples in the collapsing Vavilov ice to create three-dimensional evolving topography. Here's what went into that. Starting from a flat version of the landscape, we add the time-interpolated topographic relief and use Landsat optical imagery to provide color. It too is interpolated over time. Over wintertime darkness, we again alter the landscape color and lighting, and the sky, to suggest dim twilight. As springtime returns, so does Landsat imagery. The sun's very low as spring begins, so the early Landsat images are tinged pink with sunrise.
So I wanted to share my contact information as well. As part of iGuide, in the next phase of this project, we are looking for opportunities to partner with individuals and teams to create cinematic visualizations. So if you're interested in this sort of collaboration, potentially you have data that you'd like to visualize in this way, feel free to reach out to me. If you feel like you don't want to reach out to me, but want to learn how to create these visualizations yourself rather than partnering with us, but don't know where to start, we created a 4-week Coursera class that you can check out and learn about an introduction to cinematic scientific visualization in more depth than what I was able to go into today. So I also included these resources, and I'm resharing Vitria's slide plus my information as well, in case it's helpful for anyone to take a screenshot and have everything all in one place. So I'll leave this up for a few more seconds, but that concludes the presentation that I have for you today. Thank you.
Thank you, Kalina. That was fantastic. So we'll begin the discussion part, and I encourage everyone to use the Zoom Q&A to ask questions. We have a few there already. I saw the first was actually to put that slide up from Grace Wolf Chase, and I just want to say, hi, Grace, how are you? But anyway, my former colleague. Let me ask you this a question for both of you. What is when you see scientists produce their own visualizations, what is one of the most common or maybe frustrating mistakes that you see scientists continually making that you wish they would stop? So Vetria, maybe start with you.
I think first thing is identifying valid data sources. You know, at one point there was a time when we couldn't find enough data, and then now there's like an abundance of data, and trying to figure out, you know, what data best represents the questions that you want to try to answer, and then also getting it into the format that it needs to get to be in order to get it read it into the tool that you're going to use. And so I think one of the challenges is that sometimes we think about, we have a visualization application that's for a specific thing or specific project, when in fact it can be used in multiple and different ways. And so I think just kind of locking in on this is for this particular data set, or this is for this type of data, oftentimes presents to be a challenge for a lot of people.
Thank you. Kalina?
I don't know where to start. There's so many things. I guess, yeah, too much. So a couple of things come to mind. One is that a lot of times visualizations that I see created by scientists try to cram in all the data that they can into one image, just because, you know, there is so much data. There's often, you know, many variables in a data set, and a time series, and changes in space and in time, and lots of variables. Putting it all in onto one image is not really an effective way of getting that data out there. I understand why scientists want to do that, because they have all this data and they want to put it out there. But you know, sometimes when making an image for like a publication, sometimes one of the goals is to kind of show how much hard work you did and want that to come across in the image. But really the goal shouldn't be to show off how much work you did, but the goal should be to try to communicate the science. And that often requires simplifying. You know, maybe it might make more sense to break apart an image into several rather than trying to cram it all into one. The other thing that comes to mind is leaving software defaults. Things like default color maps can be pretty problematic. Oftentimes in scientific images, you'll see a lot of rainbows, and those have been proven to be perceptually confusing because rainbow color is cyclical, right? It goes from like red to green to blue back to red. So it's difficult looking at an image like that for an audience to know, like, well, is red more or less than blue? That's not very obvious. So simplifying in terms of color, and kind of not just sticking with software defaults because they are applied that way, but trying to actually create something custom for that visualization to convey that particular data set better.
Yeah, wonderful. Let me turn to a question from Jinwoo Park, who thanks you for sharing the sort of fantastic visualizations, and suggest for someone who's new to scientific visualization, what are some, like, and I guess some of these were in some of the resources, but what are some of the key concepts or tools that would be easy for them to implement in their work?
I think becoming familiar with what the different principles are and the different types of things that can be done, I think is a first step, because in any basic visualization application, you should be able to do the rendering. You should be able to, in particular scientific visualization, to do scalar visualizations, or to look at different slices of the data and to render it in different ways. So I think just becoming familiar with just what the basic principles are and understanding how to apply them, I think that will be helpful. Because oftentimes, if you're new to scientific viz and you open up an application that has all of these different features, sometimes it can be overwhelming. And so much so that you maybe get discouraged. So I think the first step would be is to find maybe a sample data set to play around with and familiarize yourself with an application that will allow you to explore the data in different ways. And I think that that will help you to start building your confidence in your ability to be able to make sense of that data in a scientific landscape.
And if I can add to that, in terms of kind of the learning the principles, I think it's especially important if you're coming from a science background to really look into the design side of it. A lot of times scientists focus on, the science and the technology and like, how can I do something with the data or like write code to make this work? But it's not just a technical problem, it's also a design problem. So learning about things like, I see someone mentioned Edward Tufte in one of the other questions. So that's like a name that has a lot of good introductions and best principles, kind of more from the design side of things. There's that could be a good place to start and look into, actually.
All right, thank you. I'm going to ask you a silly question now, if I could. Just thinking about sort of geospatial visualizations, and really the sort of most basic visualization is a map. And one of the challenges that we're always dealing with is choosing among map projections. And I kind of love this XKCD cartoon, what your favorite map projection says about you. So, like, I kind of like Robinson projection. It's like you have a comfortable pair of running shoes that you wear everywhere. You like coffee and enjoy the Beatles. That's all true about me. So my sort of silly question for each of you, and then I'll have a serious one about map projections as well. But the silly one is, what's your favorite map projection and why?
I love this question. And I think the kind of the cheating answer that it was kind of labeled that way on the graphic is a globe. But because I do, most of my work is in 3D, I create these 3D virtual environments and fly around the data in that sense. Whenever we can work in a globe, we do. It's pretty rare that we need to create a final visualization that is flat. A lot of times we have to do kind of processing on the flat data set and then do conversions between different formats. But just because I have the privilege to be able to do kind of these three-dimensional data visualizations and representations, I get to go with the easy answer and say globe.
So can I get you to put your slide back up?
Sure.
A second.
Sure, happy to.
And the reason why I say that, I guess this is Dymoxion, the one next below the globe. Mm-hmm. That one or either the one below it. The reason why I say that is because in my classes that I teach, we start with information visualization, which is does not particularly include geospatial type data. But as we move into looking at the different types of categories or areas of data visualization, one of the things that I do is I bring in those little halos, those little tangerine little things. And we have the challenge is to peel the halo, and you have one piece, it can't be broken up. And so what we do in class is we think about how we're going from one form to another, from a 3D representation to flat, and then also thinking of how that might look if we were to start from a 2D representation going into a 3D representation. And the students seem to respond well to that. And so I like that as a conversational piece and as a way of getting them to start thinking about more complex elements of data visualization, moving from information visualization more so to scientific viz, or looking at different ways in which you can visualize latitude and longitudinal data.
Yeah, thank you. All right, so now the serious side of that is that these choices that we make matter, right? So we know, it's well known that a Mercator projection, which is one of the most common that you'll see out there, greatly emphasizes the area of northern latitudes. It makes Europe look gigantic. It shrinks Africa. So there are the choices we make have impacts for equity. And I guess my question is, like, what are some of your thoughts about that? What are some of the choices that we're making which have unintended consequences?
That's an interesting question. And in fact, this week in our class, we were talking about diversity, equity, and inclusion in data visualization. And one of the things that I try to impress upon students is making sure that we include all persons, and we make sure that there is good representation in the decisions that they're making in terms of how to represent the data that they're working with. I think that it is a good conversation to have, but then it's also one in which not a lot of attention has been paid to it, because as Kalina mentioned, sometimes you have scientists, myself included, we want to get all the data information out there and not really pay attention to who's impacted or who we may or may not be excluding. And so I think we have to put that at the forefront in terms of our process, the design process, as we're thinking about how best to represent it, but also to make sure who we're representing, or more importantly, are we leaving anyone out? And so I think that's it has to be a part of the design process itself, so that we make sure that we're reaching all persons who may be impacted by it.
When we're creating our visualizations, they do go out to the general public around the whole world. They get, even these documentary films get translated into other languages and then distributed internationally. And this is a concern because we are a bunch of Americans creating these visualizations, and we have our biases based on where we're from and where we are in our experiences. And something that we've just recently started doing through this new grant that we have a part of is doing more in-depth focus groups and audience research to actually put our visualizations in front of test audiences and see what they think about them, and see if they get what we think they're getting out of them, see if our design choices are effective. Because just because we think something makes sense or is obvious doesn't mean that someone on the other side of the world or with a completely different background might think is obvious. There are certain cultural things, like we in North America might assume that people read text left to right, top to bottom, so that like if they're scanning an image, they might start by looking in the top left corner. That's true for us here in the US, but is not true in other parts of the world where text is read from right to left. Or things like color maps. Colors have different associations. Like we often associate like green with good and red with bad, or like, a stop and go or things like this, but those colors have different meanings in other parts of the world. I think there's always more work to be done in this. And this is something that we've just started looking into recently, having these actual formal focus groups and formal studies with our audiences. But I hope that we get to do more of that and that more people will do this, because it is very important.
Can I add just one more thing is that we also have to be aware of the different colors that we're choosing. And we want to make sure that everyone can actually see those colors that are represented there. And so thinking about different ways in which we can display things in the absence of color, but still convey what we're trying to convey. So I think that's one of the challenges as well to be aware of.
Yeah, those are great examples. You know, I was thinking when Kalina was talking about different parts of the world, of being in a planetarium in South Africa and doing a simple thing of turning the globe upside down, so south was up, you know, made a big difference. Things like that. Let's go to a question from Gabriel. It has to do with interactive scientific visualization. So we saw some great examples of movies, but Gabriel's reporting a sort of eureka moment when seeing a presentation of the Gaia Sky software, which is a pretty incredible piece of software which can interactively visualize 1 billion stars. And there was a scientist from the Hipparchus mission who was in front of the visitors and asking if they could highlight error bars, and they did this interactively, and they saw some artifact due to an instrument. Anyway, the story was like in real time, very quickly, with this tool, they were able to see some important scientific feature. And so what are your thoughts about the ability to do interactive visualization at scale now, you know, at large scale? And what's possible, and if maybe, you know, I don't know, like maybe for your group, Kalina, is that thinking about changing some of your workflows?
I do absolutely think that interactive is the future, not just in terms of from the audience's perspective of being able to interact with the data, which of course is very valuable, but even on kind of the back end of creating the visualizations, being able to do so interactively would greatly improve the speed and ability that we have to iterate and make changes and create renders. There are certainly people creating interactive visualizations already that look very beautiful and are getting pretty close to cinematic or even photorealistic. There are limitations still, of course. Maybe, you know, 10 years from now, that will no longer be the case, or in the more distant future. But for now, a lot of the data sets that we work with are very large. So we're at a supercomputing center. We work with data sets in the tens of gigabytes to tens of terabytes in scale. So it's not feasible with current technology at full resolution to show that data in real time. It's just a matter of like, we can't physically read that file fast enough. It's not even about drawing the image. It's that too, but just the IO is limited. So that technology isn't quite there yet, but I do think it is heading in that direction. I know that like the film industry, for instance, not talking about scientific visualization, but cinema in general is moving in that direction already, doing a lot more work in game engines, and not just to create games, but to create films. Like the work is created in a game engine, but then it still ends up being a video in the end. So it's kind of this combination of using interactive technologies on the back end to create the visuals, and then also, of course, creating interactive visuals that the audience can play with themselves. They're both valuable, and I think that time is coming, but it's not here yet, at least for the scale of data that my team has been working with.
Vetria, do you have any thoughts about interaction versus sort of like static visualizations?
Well, I agree with everything that Kalina said. I will add to that is that as people are learning how to do data visualizations and creating them, I think they need to be aware that integrating or adding the interactive feature should enhance the data and not distract or take away from it. And so I think that's one of the challenges when you're new to it. You want to add all these nice and fun features, but you also want to stay true to the nature of the data. And so I think one of the challenges, I agree with the challenges that Kalina has mentioned, is that as a everyday user, we don't have access to the technology that will allow for the real-time rendering. We have we want instant gratification. You know, we click and if nothing happens, we're on to the next thing. And so you have to take into consideration, you know, the resources that you have available. I don't think that we're there yet, but we are moving towards that type of environment. But until we get there, I think, you know, having a conscious awareness of, you know, you're creating or adding the interactive feature to be to enhance what you're working with, not just to create it, not just to have interactive features just to have.
Great. Here's an interesting question from Clifford Jacobs. So there's a trend in journals to publish the data used in scientific articles. Also, the NSF is interested in preserving and making available data created from funded projects. And so the question has to do with data visualization products and making that data available, perhaps the code available. It's something we've been thinking about, especially as we do more work in climate, and there's so much mistrust of climate data, being able to show not just, you know, where the data comes from, what the data source is, that whole provenance, but also like how were those images created from the data. Yeah. Anyway, just thoughts on making available the data and the code behind data visualizations.
I think, especially from someone who's teaching data visualization and trying to bring others into the field, having access to data or previously published or rendered data is useful, particularly for those who are new to the field. Not only just having data, but having some good examples of what it means to document the data. You know, I think that's one of the challenges that we face is when you get data, like you just mentioned, where did it come from? What were the things that what did you do to transform the data or to get it into the format that it needed to be in? What decisions that you make, whether that's administrative decisions or, you know, just in using the data, who was the intended audience, you know, those types of things, and what assumptions, very important, what assumptions are you making? And so we make assumptions all the time, whether we realize it or not, when we're working with data, and those assumptions impact the output that you have. And so I think one of the goals of sharing is so that others can reproduce or generate similar things based on what you've been able to do. And in order to do that, I think it would help to have at least a model to look at, to guide us through. So I am in favor of sharing for that reason, is to allow or to help others, bring them into the fold. And like I said, to help build their self-confidence and self-efficacy in their ability to actually do data visualization.
I'm absolutely in favor of this as well, in theory. However, in practice, it proves to be quite challenging, especially for the type of work that my team produces, but I guess for anyone's visualization work really. But in terms of our outputs, you know, if we create a visualization for a documentary film, and, you know, someone sees that on Amazon Prime or on television or in a movie theater, how point them at the data? Really, the only thing that we have access to is crediting the scientists and the data, like in the scrolling credits at the end. Does anyone pay attention to those? Probably not. Is it the best solution? Probably not. So this is kind of an unsolved problem for us as to how to handle this. When we do post our visualizations online, like on our own website, we do include information like who the scientist was and who they were funded by, and, you know, these important kind of side elements. But unless people go to our website, they're not really going to see that. And I think most people see our visualizations in other formats. Like oftentimes our viz ends up in really weird places. Like it showed up as a background in the movie Annie recently. There was one of our visualizations. Can't explain why, but there it was. Or sometimes, you know, they'll pop up on Reddit. And when people are taking these visualizations and using them, which they're free to do, they're free to use for educational purposes or whatever reason, oftentimes, you know, they'll trim off those credits or sometimes even miscredit the visualization. I've complained to Mark about this before, but our viz gets credited to NASA every once in a while. So it's an unsolved problem. I would like to solve it, but don't have the answers.
Yeah. The point about once things get out in the wild, right, they can be used in lots of ways. And I certainly have had similar examples of just seeing some of my stuff in places I didn't expect it. But there's also times where you see it not just used unexpectedly, but misused. Do you have any examples of like misuse of visualizations that?
Not that I could think of. I'm sure it happens, but I don't know all of the examples of how they end up being used.
Here's a question from oh, let me scroll back and find it. Tao Wang. Two questions. One has to do with how do you ensure that the noise or errors in the raw data do not affect the true pattern of the data? And I guess this really gets at a lot of what the visualizer's job is to try to, and this really has to do with the storytelling aspect. And really, you could say that almost any kind of visualization, even if it's for a professional audience of storytelling, you want to decide what you're trying to show, and you can't necessarily show everything. So like, how do you deal with noise? But I also think, we saw this in the one example video, artifacts are often the thing that really shows up. Data artifacts distract you from the patterns, and how do you deal with that? And then there's a second question, which is a different one and a very big one, and a real visualization challenge, but which is how do you show uncertainty in a visualization, which is of course, so important to science, but not often the easiest. I mean, we all know about error bars, but often a challenge to do well. Maybe Vetria, do you have thoughts on those?
Yes. So the first question, can you repeat that? I was listening.
Yeah, I mean, there was the aspect of making sure that you're not overwhelmed by the noise. Like
Oh, okay.
if you're,
Yes.
you're visualizing something where the signal isn't very strong.
Right. So I think that gets back to the point that I made earlier about communication. And I think it's an excellent point that Kalina pointed out, is that she's not an expert in all of the things, of the expertise that's in her lab, but you do have experts in those areas. And so I think communicating with the people that you're working with to make sure that, it's particular if they're providing you with the data, to make sure that you are creating the visualizations as they are intended, and also showing what they want or what they expect to see. So oftentimes I worked on projects where I was not the expert on the team either, but I was helping to provide some visualizations. And so communication is the key, I think, in having those conversations with the people that you're collaborating with. That will help you as the person who's creating the visualizations to know, in fact, if you are staying true to the nature of the data. And so that would be my, I think, suggestion for that part. The other part, how do you visualize uncertainty? There is a body of work, I think there's a lot of work that's being done in that space. I think that we have areas in which uncertainty is visualized. We looked at weather. That's the example that I usually go to. Mother Nature is Mother Nature. We can only make predictions. And so that's a lot of uncertainty there. When you look at the different models that are used in terms of predicting weather patterns. And so I don't really have a strong answer for that, but I do know that there is a body of work that's out there, people that are working in this area in terms of what's the most efficient and effective way to do that. So I do apologize. I don't have a strong answer for that, but I do know that there is work being done in that area.
There's an interesting example recently with Hurricane Ian, right? And I think many people are reporting that the forecasts were completely off because it trailed from the center line, but it wasn't really too far outside of the range of predictions. Of course, we all know about Sharpie Gate, and this, this general misunderstanding. People see this cone of uncertainty. They think that means that's a visualization of the hurricane getting bigger and bigger, when it's really just showing our location of where it is. So that's definitely a case where, especially when you have things that are being read by, a public audience who's not expert in what they're seeing, your visualization can be misread. I also noticed that we're past 5 o'clock. So we probably should start wrapping this up, but I'll give you an opportunity to comment as well. Clean on those questions if you want.
Yeah, sure. So in terms of the noise question, it really depends on the story that you're trying to tell with the data and who your audience is, right? So if the reason you're visualizing the data is to see how accurate the sensors are, well, then you should certainly leave the noise in because that's part of the story that you're trying to tell. But if your audience is, 8-year-olds going to a museum, then you certainly want to remove that noise because it's going to be very confusing and you don't want to have to get into explaining, how that got there and why it's there and why it's removed, because that's not part of the story. So there's no one size fits all answer in how to treat noise, whether to get rid of it or whether it affects the data if you get rid of it. It all just comes down to what the story that you're trying to tell is. And any visualization that you create of anything, you're going to have to make certain design decisions. You can't just ever show all of the data in its raw format. That's just simply not possible. So in a sense, you're always going to be doing data collection or data selection or data cleaning. It's just the extent to which you do that, where you have to kind of draw that threshold. So that's all I have to add to that.
All right, well, thank you. And thank you both. And thanks to all the participants, and thanks for all your great questions. And I apologize we weren't able to get to all of them, but hopefully maybe some of us will be able to type answers in the chat if we can. But yeah, once again, thank you all for joining us. I don't know if anyone has any last words before we sign off, or
I just wanted to add that please, if you are not already signed up to receive the iGuide newsletter, we have a lot of announcements about future events that we will be hosting. So please make sure that you keep in touch and watch our Twitter feed, our website, and also for future editions of the newsletter. And that will give you an idea of the things that we're up to. So thank you again so much for your attendance today.
Thank you.
Thank you.